So now that we have that, we're going to try this one more time. Let's see how we do. Let's see if this will let me scroll. So here we go. Our last proof, we do have one more theorem, and we'll actually write this down as well. After you do this proof, just as a wrap up of what we did today, there's going to be 2 new boxes filled in our yellow pages. All right, so if you would, just follow along with me. By definition, here's a theorem. The radii of a circle are congruent, and I'm actually going to go a little bit more specific. Not write the word a, I'm going to write of the same circle are congruent. Okay, just to be more specific. The symbol for a circle is this, a circle with a center, like that. And here we are with another level 2 proof. And it looks like we need to figure out, based on what's being proven here, we need to figure out which 2 triangles to prove congruent first. And so let's mark up the diagram. So if I'm given a circle, then I know the radii are congruent. So remember, radii start from the center and go to the circumference of the circle. And in this case, segment MA is yes congruent to segment MB and MC, but is not as helpful in terms of looking at 2 triangles are congruent. So our goal will be to try to prove triangle MNB congruent to triangle MNC first. So if you wanted to pause right now, I would actually try to do this first. Can you get us up to there? And then you can check along with me. So I'll give you a moment to go ahead, pause if you'd like, and then try it, and then come back. All right, and so if I have my circle M, I get the 2 radii there, and then segment MN bisects segment BC, so that means these are congruent. And then I have to look for a reflexive side or angle, or vertical angle. So no vertical angles in this one, but I do have a reflexive side, MN congruent to MN. So if I look at my triangles, it looks like with the goal here, if you tried this without me first, they should be congruent by side, side, side. So let's see how you wrote it, okay? So circle M, given. Well, that made us get segment MB congruent to segment MC. All right, and we'll just write our theorem from up here. All radii, that's kind of a fun and funny word, of the same circle are congruent. Okay, I'll go with my second given. MN, segment MN bisects segment BC, given. Like that reason a lot. Well, that just meant that segment BN is congruent to segment NC. Well, what does bisect mean? Well, remember, bisect means to cut something in half. So if you look at step 3, a segment that bisects another segment divides it into 2 congruent segments. That's all. You're just telling me in your reasons what happened. Okay? And then our last set of sides is that reflexive side. So MN is congruent to MN, segment MN, by reflexive property. Super useful. So now we can say, since I have my 3 matches, triangle M and B is congruent to triangle M and C by side, side, sides, which I showed in steps 2, 4, and 5. Okay? I'm going to use a different color to get us through the next part. So we want to prove that ray MA bisects angle BMC, which means I probably need to show which angles are actually congruent. And so if that ray is bisecting the angle, if I look here, call that angle 1 and angle 2, I actually need to show those 2 angles are congruent. All right? So I'm going to say angle 1 is congruent to angle 2. And how do I know those angles are congruent? Well, remember, our new thing for today, If you've already shown the triangles are congruent, then you can say any set of other corresponding angles or sides that you haven't shown yet are also congruent. And so angle 1 and angle 2 in that picture are a set of corresponding angles to those triangles. So you can say for your answer here, your reason, CPCTC. Or if you don't like that, you can say if two triangles are congruent, then the corresponding, and we look, their angles are congruent. Okay? And then we can finish it off. Right? Ray MA bisects angle BMC. Okay? So what happened? Well, if a ray divides a segment, and this is from chapter 1. Oh, I'm sorry, it doesn't divide a segment. If a ray divides an angle into how many parts? Well, 2, right? Into 2 congruent angles, then it bisects that angle. And then that's it. That is it. The definition of having a bisected angle. All right, so I'm going to zoom out a little bit so you can see everything here. Nice job following along and trying things out. All right, and now we're going to write in our yellow pages. So if you would, take out your yellow pages. We'll need 2 spots. So for me, I know that means I'm going to another page after this last box. Okay. All right, so the first new thing here was CPCTC. And if we want to write this down, corresponding parts of congruent triangles are congruent. Oh, and I noticed some of my letters from before disappeared up here, so let's just add them. NOH triangle. AOH. Okay. That looks better. So there's your C, P, C, T, C. Okay. Write a big note here. Only used after proving triangles congruent. You can't use it any earlier. Okay? Another way to write this, if you'd like, remember you could write if 2 triangles are congruent, then the corresponding sides are congruent. Or you could write if 2 triangles are congruent, then the corresponding angles are congruent. Instead, if you don't want to write CPCTC, that's fine. I actually like writing out the statements more, but if I'm in a hurry, I write CPCTC. So up to you. I will understand all of that. All right? When you're done writing that, just flip to the next page. We're just going to write about the radii here. All right. All right. And so, oops. All right. There's really not a specific name for it. Radii theorem. Okay, just so you don't forget. You're gonna write all radii of the same circle are congruent. Circle, remember this means circle. All right, means circle are congruent. This is one of those things I want us to write down because it's actually new. It's not from chapter 1, it's not from chapter 2 or any other of the chapters before this, and so that's why I wanted to write it down. All right, so that's the lesson for today. It was a little bit longer, but we're going to get a lot out of it, and then tomorrow, Tuesday, we'll just do some practice together. All right, nothing new, just some practice. All right, be good, have fun at eSchool, and I'll talk to you tomorrow. All right, bye.